Erez was talking about the next big thing. I want to talk a little bit about the current big thing. 5G, of course, no one can miss hearing about it. A lot of it's hype, a lot of it's promise, but a lot of it is risks as well. So I want to talk about the 5G promise versus its vulnerabilities and what Allot can do about all that. So basically, what is the promise of 5G? What is the effect of 5G is going to have on our world? Well, first of all, the thing you can't miss and you hear all the time in all the advertising is that 5G is going to deliver faster data rates. And that's already happening. In fact, in North America, we're talking about doubling of the rates on mobile as compared to just a few years ago based on 5G penetration, which is pretty important already. But that's not the real major effect that 5G is going to have on our world. We have to talk about the other effects as well, such as lower latencies, which is going to be important for new applications such as augmented reality, smart home, etc. Higher connection densities, that is many more connected devices. We're talking about, in the massive IoT case, up to 1 million devices per square kilometer, which are things that 4G can't handle. Higher QoS, 4G does define QoS classes, but really is not delivering on promising QoS, and 5G is going to deliver something called slicing, which we'll talk about in a moment. Cloud services, 5G is going to naturally interface to cloud. It's going to use the cloud for its own purposes, and it's going to enable new services based on the cloud. And we're all using the cloud already today, but mostly from our fixed networks, and we'll be able to use it from anywhere ubiquitously under the 5G moniker. And all sorts of new services, such as Smart X, where I mean smart home, smart utility, smart city, smart factory, which is called Industry 4.0. PVN is the private virtual network, which is going to be much more than what VPNs used to be. Enhanced fixed wireless access. People are talking about 5G to be the one network to rule them all. If 5G really works, you don't need anything else. You don't need separate cables for your television and for your internet at home. 5G will do everything for you. And all sorts of even more modern applications, such as connected car, AR, I already mentioned before, RedCap and critical infrastructures using 5G, and etc. So 5G, if it delivers on all these promises, is really going to be a big thing. It's not just hype. However, already at this point, we can mention that there are points where Allot's next big thing matches what 5G can deliver. In a moment, we're going to talk about what 5G is going to deliver and how we can help that as well. I think Erez mentioned before that what we do in Allot can be divided into 3 categories: C, control, and secure. From the C point of view, we can deliver for mobile networks in general, for 5G specifically, analytics, where we can see applications, we can see user behavior, we can see individual device behavior. We can notice that performance is degrading. We can score the quality of experience, not just the QoS of various applications, including video, which is a high percentage of what people are using both in their fixed networks and their mobile networks. And we can assist in billing based on either application or volumes. All that based on looking at traffic. As Erez mentioned before, we see every packet and we can understand what every packet is doing. The second portion is traffic management, where we can allocate the bandwidth, we can enforce data caps, we can prioritize based on application, we can take care of congestion when it happens, we'll mention that in a moment, and we can do policy enforcement for tiered services. And finally, secure. Here I only have 2 bullets, but that's because the rest of the slides are going to be focusing on this topic. So the vanilla bullets are, we can certainly block malicious traffic, and we can do DDoS protection, both in the inbound and the outbound direction, but that's just the surface. We'll be talking about a lot more. Okay, so the current situation with 5G is basically that we're seeing 5G come up everywhere around the world. There's a tremendous amount of 5G already. However, 90% of it is what we call NSA, or non-standalone mode, which is basically 4G on steroids. It's not really 5G. It uses an overlay of the 5G radio above the infrastructure of 4G and the core of 4G. And therefore, the only thing it delivers on is the faster data rate and not the other promises I was talking about before. Now, this is already a bit of a problem because with faster data rates and additional data, in addition to the 4G that's already there, we're talking about having to upgrade the backhaul, that is the portion of the network which takes the traffic from a cell site and brings it back to the core. And backhaul upgrading can be expensive. So Allot can already help out there because Allot solutions are both high capacity, as Erez mentioned before, and we can, with our congestion management, help either avoid entirely or delay costly upgrades of the backhaul infrastructure. So even with this simple kind of 5G, which I called before just 4G-like services but faster, we can already help. However, the real promise of 5G is the next step, where we're going to have the 5G core itself, not just using the 4G core, but we're having the 5G-C, the 5G core. This is where the real innovation of 5G is going to happen. There are certain technical things like the separation of the user and its mobility portion from the session management, but more importantly, we're going to have support in 5G for quality of service, and this thing I call network slicing. Network slicing is where you have different kinds of services running over the same network, but without interfering with each other. Each one gets the QoS it requires from the network, and even if it becomes overloaded, other services are not affected. It also, in the 5G core, has new routing and traffic forwarding paradigms, which revolutionize the way the packets are moving around inside the network and between users. We have this cloud-based core, which is based on the modern microservice architecture and REST principles that we're used to in our daily lives in the internet. All the hyperscalers are based on these same principles. And more importantly, the 5G core is going to support third-party functionalities. It's going to be able to expose third parties because the mobile providers understand they can't do everything alone. And this is going to be part of the infrastructure and therefore enable all sorts of new things to be done relatively simply. And very importantly, the 5G core was designed from the first day to be secure by design. Now, what do I mean by secure by design? Well, unlike the previous generations where security was tacked on, and by the way, the same thing with the internet itself, 5G, when they started talking about how they were going to make the core, they decided from the get-go that 5G security was essential. So a new security architecture was defined. The crypto functionality, which protects the traffic, was upgraded. There's a new authentication and key agreement protocol, which includes the fact that you never transmit identifiable labels having to do with the user over the air. Everything is protected, so you can't do any stingrays and things like they used to in the past to follow particular users. The protocol uses modern secure communications technologies like HTTPS, which we're all used to using in our daily lives and is state-of-the-art from the point of view of security. There's a single data store. That is, rather than having many functions keeping data about the users, it's all in one place and using modern technologies of how each particular piece of information can be secured. Only certain network functions can look at it or can change it or can erase it, etc. There's the isolation of the core and between the core and the RAN, the radio access network, and different cores from different operators are isolated from each other with highly secure protocols. And finally, those third-party functionalities, which I was mentioning before, are thoroughly authenticated. So this sounds great. 5G is secure. We can all rest and figure out that 5G is going to solve all our problems, correct? Well, not so fast. It turns out that real security experts are worried about 5G. And why is that? Well, actually, The very features which make 5G so innovative are the ones which make it scary from the point of view of security. This security by design I was talking about, in essence, was security by design of the 4G network. It was basically looking at the 4G core and seeing how we could make that more secure. But the 5G core and the 5G network, as we mentioned before, is now much more innovative. It's based on software and cloud technologies. And anyone knows anything about software knows you can never totally secure software against sophisticated attackers. Software is being coded around the world using open source packages, and anyone who follows the CVEs knows that there are always new vulnerabilities being found for open source. And in order to reduce latency, as we mentioned before, many of the functions are being put in the cloud, but not in a centralized data center, but rather in what is called the edge cloud, much closer to the end user in order to reduce the latency. And once you have something further out, not in a centralized place where you can put a perimeter around it, it's much harder to secure. So people are worried about 5G security. I'd like to give a list of 5 things, which is certainly not an exhaustive list, but 5 vulnerabilities which we should address. And I'd like to show you that actually Allot not only addresses them, but in a sense, these very vulnerabilities of 5G play to the strengths of Allot, and Allot is well positioned to address them. So what are the 5 vulnerabilities I want to talk about? The first one is that 5G can be faster. And Erez already mentioned that once you have faster and more users coming in, that's more attack opportunities. It's much more traffic to have to look at, much more traffic that you can try hiding malicious traffic in. Number 2, some of the 5G services, certainly not all, but many of the interesting new services are low latency, and that gives us 2 problems. Number 1, there are new kinds of attacks which simply delay packets rather than actually infiltrating a system or erasing packets or introducing new packets. And delaying packets which have to be low latency is already a problem. But even more so, the typical solution of rerouting packets to a scrubbing center where we can really look at them carefully adds a lot of latency. So you might actually be able to get rid of the problematic malicious traffic, but at the expense of delaying the time-sensitive traffic and basically not living up to what 5G is supposed to do for low latency services. The third one is that 5G is more distributed. As I was talking about before, we have these edge clouds. Edge clouds in the 5G terminology is called local breakout. Rather than all the traffic going to a centralized core, we can locally break out traffic and go to the internet or other packet networks. And the thing I'd like you to remember is that local breakout facilitates a global break-in. There are more places that you can get into the network rather than going through a central site. It makes it much harder to keep malicious actors from getting into your network. 5G supports all sorts of new traffic types. In the beginning, we were talking about 3 basic traffic types, EMBB, URLLC, and MTC. We now have an additional one, reduced capacity, RedCap. And this is all going to be eventually solved using this hard isolation network slicing I was talking about. Unfortunately, no one sees this happening really, really soon. And so right now, attacking one kind of traffic can have a after effect on other kinds of traffic, and we don't really isolate them very well. And finally, as I mentioned at the beginning, the 5G core is no longer network equipment. It's no longer boxes. It's pieces of software, small pieces of software, which are going to be provided by all sorts of software vendors. So it'll be more readily possible to add malicious network functions, or to take over existing network functions, or to exploit problems in network functions having to do with open source. So how is Allot going to address all this? We'll do it one at a time. We mentioned before 5G can be faster, which means that there are more opportunities to attack the network. Well, this is actually playing to one of Allot's core strengths. Allot makes boxes which are high capacity, very high capacity. We're not talking about gigabits per second, we're talking about terabits per second. So we can actually look at all the traffic, even though we're talking about 5G rates, and see where the threats are and take care of them at the rate the traffic is coming there without having to go to some scrubbing center or something of that sort. Second, the low latency problem, which we said led to two problems. Well, the low latency is actually, once again, something which is good for Allot because our solutions are inline rather than the standard solution in 5G, where you have several different functions, one which is looking for the vulnerability, one which is now deciding policy, and then going down back to the user plane function to try to do something about it. We are inline, minimal latency. We take all the traffic, we can filter it, block the bad stuff, all in real time with very little added delay. We are talking about 5G being more distributed, including in edge clouds, which gave this problem of the local breakout. Well, Allot has solutions that can basically are software solutions. They can sit on bare metal, but they can also be deployed as virtual machines or as containers using modern cloud orchestrated techniques. So we can be part of the 5G cloud as a third-party function, as I mentioned before, and we sit there in the distributed cloud and work together with the other elements in the distributed cloud. The different traffic types and the hard isolation not being there, well, you can actually think of Allot's core technology of DPI as being a kind of soft slicing, but highly granular. In other words, rather than just 4 or 5 different traffic types, we can actually differentiate based on individual applications and provide many of the benefits of slicing. For instance, if there's an attack on a certain kind of application, it will not affect other applications and we'll be able to isolate it. And finally, the problem of network function software, which can be either malicious or taken over. Well, we can look at all of the traffic and measure the load of the different network functions and be able to discover that a network function is behaving in an anomalous manner. We can see that it's doing things it shouldn't be doing. It's sending traffic to places it shouldn't be sending them, or all of a sudden has load patterns which are incorrect for that particular network function, and raise the flag in time for the operator to do something about it. So as I mentioned before, rather than being just vulnerabilities and problems for the operator, these very problems that we're talking about actually play to some of Allot's key core strengths. In summary, the current generation of 5G is mainly what I call the 4G on steroids, but that's okay for our point of view. Not only can Allot scale up to the needed data rates without having to do a replacement, we can scale our solution so that it'll be an incremental amount of expenditure for the operator. But not only that, we can help the operator control his costs by perhaps delaying backhaul upgrades and certainly providing congestion management so that the key applications are not affected even if the backhaul is becoming somewhat more congested. However, that's just for the present kind of 5G. For the full 5G, which has that 5G core with all the new features and all the new promises that 5G is going to deliver on, all the new innovative services, there is where we actually can shine because we can resolve the security issues, all these new security challenges, in addition to handling the extra quality of service requirements and the very architecture of 5G, which will be difficult for other vendors. And finally, as I mentioned before, the Allot solutions actually fit into the new 5G core architecture. We can be deployed as virtual machines or as containers and orchestrated from the cloud. So we hope that that means that we can address both the quality of service problems as in addition to the security challenges that we have to address in 5G. Thank you.